friction acting here on the section on the right hand side. We're told that the coefficient of friction is mu, and that will be on this section here in the middle. We're told that the system is released from rest and C will move down the plane. So this point C will move down the plane, which means that B will follow C, A will follow B, and if B is moving to the right, that means friction will be moving to the left. We've got to solve an equation or find an equation in terms of mu, A and G, and we've got to show that A is going to be less than 1/9 of G to root 3 minus 1. And then in part B, you were told that A is equal to 1/9 of G, and you've got to work out the magnitude of the contact force between B and the horizontal plane. So you've got to find the contact force at this point here, B. Now our key facts are that we need to put all forces on the diagram. So every particle here must have a weight, so you need to include the weight on your diagram. You need to include the normal reaction force, you need to include the tension, and you need to include friction. So make sure you include all these forces at all 3 points here. Next, we're then going to resolve vertically. So we're going to use Newton's third law, and Newton's third law says that the forces up equal the forces down. Now that is going to be applicable here at part B, but at part A and part C we're going to be resolving perpendicular to the plane. Next, we're going to resolve horizontally, or down the plane or up the plane, depending on if it's a slope or if it's flat. So we're going to resolve horizontally using Newton's second law, which is F equals ma, where F is the net force, m is the mass, and a is the acceleration. Then we're going to combine these two formulas I've just worked out. So at the top I will have worked out a formula involving R. Next I will have worked out a formula including the friction. So friction will equal mu times R, and we're going to use this formula. The last part of the question wants to know the contact force. Now the contact force can be calculated by you doing the square root of R squared plus the friction squared, where R is the normal contact force and Fr is the friction. Now when you come to work out the contact force, you need to have found the friction, which will be acting to the left, and you need to find the normal contact force R up here. Once you've got these two forces found, then you can draw in the normal contact force. Now the normal contact force is a force which is basically the resultant force of your reaction force and your friction force and your normal reaction force. So your normal contact force will be going at an angle up here, but you do not need to draw that diagram with the force, the normal contact, the contact force in until after you have worked out what R and the friction are. Now we're going to draw on the key forces, so have a go at doing that. Have a go at answering the questions, and then press play when you're ready to hear the answer. So make sure you draw out the diagram, put on your forces, use these formulas here, and see if you can get the marks, 7 marks and 4 marks for these questions. Press play when you're ready to hear the answer. Fantastic work, everyone. Well done. So to start with, we need to put some forces on the diagram. We were told in the question that C is going to move down the plane, which means that this will move down, so accelerating going down on C. B will then move to the right, and A will move up the plane because these are all connected, so they have to stay in the same motion. Adding on the weight always acts vertically down, so we've got 2G acting vertically down, which means between the perpendicular and the downward force you've got an angle of 30 degrees. At B, I've got 3G acting down. At C, I've got 4G acting down, and this will be an angle of 60 degrees to the perpendicular. I've got a normal contact force at A, so RA. I've got a normal contact force at B, RB, and I've got a normal contact force at C, RC. I've also got tensions in these strings. So there's going to be a tension acting towards the pulley at A, and similarly at B. So this is the tension of A, B. So this one acts up and this one acts to the left. So these always act towards each other. Same on the other side. I've got a tension between B and C, and then I've got a tension between B and C here on the right hand side. I've also got a friction. So the friction is going to be opposing the motion. So the friction is only acting on section B here because this is the only part of the diagram which was rough. All the other sections were smooth. Make sure you've got your diagram drawn out correctly, and then we're going to move on to being able to see if we can work out the value of A being less than 1/9 G 2√3 minus 1 and working out the contact force. Now in section A, we have got to consider an equation in terms of mu, A and G to show that A is less than 1/9 G 2√3 minus 1. Now, normally when you've got an inequality, the inequalities are looking at using the friction. So as soon as you're looking at friction or the coefficient of friction, that's where this inequality is coming in. So we're going to be looking at something to do with this friction to be able to get this inequality. So to start with, we're going to look at B because this is where the friction is acting. So we're going to resolve vertically to start with. And if I resolve vertically at B, the forces going up are RB, the forces coming down are 3G, so I can get RB is equal to 3 times by G. And this will give me my first equation. So I'm going to ignore what's going on at A, I'm going to ignore what's going on at C, I'm only interested in this middle section here, and I'm just going to resolve vertically at point B. Next, I'm going to resolve horizontally at B. So I'm moving to the right because the acceleration is going to the right. So the force to the right is TBC. Then I'm going to take away TAB because that's going to the left. I'm going to take away friction because that's going to the left. And that's going to equal to the mass, which was 3, times the acceleration, which is A. I can now connect these two equations. So I'm going to substitute friction equals mu r into equation 2. So I'm going to replace this friction with mu r. So friction is the same as mu times by r. But we know up here in equation 1 that r is equal to 3g. So I can replace this r with 3g. So I'm going to substitute equation 1 into the equation I've just found. So TBC minus TAB minus 3g times mu is equal to 3a. Now we know that mu must be greater than 0. So there is a friction acting at this point here, and for friction to happen, mu must be greater than 0. So if mu is going to be greater than 0, I'm going to rearrange this equation to find mu. So I'm going to add 3g mu to the right hand side, and I'm going to take away 3a from the left hand side. Then to get mu on its own, I'm going to divide by 3g. So mu is TBC minus TAB minus 3a, all divided by 3g. Now we know this mu must be greater than 0, which means that the whole of this expression here that we've just worked out must be greater than 0. I can then multiply everything by 3g to get rid of this denominator here. So TBC minus TA minus 3a has got to be greater than 0, and this is my third equation. I'm now going to work out the value of TAB and TBC because I can't go any further at this stage here. So I need to find the value of TAB and I need to find the value of TBC. Now to find the value of TAB, I'm going to resolve perpendicular, okay, at A. So I'm going to resolve up the plane. So TAB minus the component of the weight going down the plane, which is 2g sine 30, is going to equal the mass, which is 2 times the acceleration. I can rearrange this to find TAB, which will give me, adding 2g sine 30 to both sides, will give me 2g sine 30 plus 2a. Now sine 30 is a half, so I've got 2g times a half, the 2 and the half cancel just to leave me with g, so TA is g plus 2a, which gives me equation 4. So I'll be able to substitute equation 4 into equation 3 now, instead of writing TAB. Before I do that, I'm going to work out TBC. So if I go down the plane at C, because I'm going down because the object is moving down, I've got the component of the weight, which is 4g sine 60. So this component here, because this is the opposite. So this is going to be sine 60 minus TBC is going to equal to the mass, which is 4 times the acceleration. Again, adding TBC to both sides and taking away 4a will give me an equation in terms of TBC. And we know that sine 60 is equal to root 3 over 2. Now 4 divided by 2 is 2, so I've got 2g root 3 minus 4a is equal to TBC. So I could substitute equation 5, which I've just worked out, and equation 4 into equation 3. So instead of writing TBC, I'm going to write 2g root 3 minus 4a, which is what I got here in equation 5. And instead of writing TAB, I'm going to write g plus 2a, so g plus 2a in here. Then I'm going to take away 3a, that has got to be bigger than 0. Expanding the brackets and putting the g terms together and the a terms together, I have got 2g root 3. My g term here is minus g. Then I've got a minus 4a. Minus times by a 2a is a minus 2a. Minus a 3a, which will give me the minus 9a. If we look at what we're trying to show, we've got a value of a on its own. So I need to add 9a to both sides. So 2g root 3 minus g is going to be bigger than 9a. I can take a factor of g outside on the left-hand side. So I'm going to have g bracket 2 root 3 minus 1, close your bracket, it's got to be bigger than 9a. So to get a on its own, therefore a is less than g over 9 times by 2 root 3 minus 1, which is what you have been asked to show. This will be worth 7 marks in the exam, so make sure you show your work nice and clearly so you can see where you're going to get the marks as you do the question. In this part of the question, we are told that A is equal to 1/9 of G, and you've got to work out the contact force between B and the horizontal plane. Now, we only are interested in section B now, so I'm only interested in what is going on here. We need to work out the normal contact force RB, which we've already done, and we need to know the friction force, and we've already got an equation for the friction force that we worked out earlier on in part A. My contact force is going to be the resultant force between RB and the friction. So we can ignore the TAB and the TBC now, and the 3G. They're irrelevant forces. We're only interested in these two forces going up and across to be able to work out this normal contact force. But these other forces, the TAB and the TBC and the 3G, will be important in able to be able to work out the value of RB and the friction. So resolving upwards at B, we get RB is equal to 3G as we got earlier, and 3 times 9.8 is 29.4. So we know the value of RB really easily and really quickly. Going horizontally at B, the same as we had before, TBC minus TAB minus the friction is going to equal to 3A. So this is the same as what we did earlier. Again, resolving A, we've already got this equation out here for TAB, which was G plus 2A. But we now know the value of A is 1/9 of G. So if I replace A with 1/9 of G, I've got 1G plus 2/9 of G, which is 11/9 of G for TAB. And using what we got at part C, I've got TBC, which was 2G root 3 minus 4A. This is what we worked out earlier. I can replace the A with G over 9, leaving me with 2G root 3 minus 4G over 9. So substituting these two values here in for TBC and TAB, I've got 2G root 3 minus 4G over 9 minus 11 over 9G minus my friction is equal to 3G over 9. Putting my g terms together, I've got 2g root 3 minus 2g is equal to friction. So by putting these terms together will give me a value of minus 2g, and friction is over here on the right hand side. So now I need to use the formula for the contact force. The contact force is the square root of the normal reaction force plus the friction all squared. So r squared plus friction squared. R squared is 29.4. Friction squared is 2g root 3 minus 2g all squared. Type that into your calculator and press equals, and you'll find you get the answer of 32.7, which will give you 4 marks in the exam. So make sure you know this formula here for contact force, and make sure that you know how to do the normal reaction force and your friction in order to be able to find your contact force. It does come up a lot on your exam, so make sure you are clear with what the contact force is. The mark scheme on this question shows that there is a method mark for getting TAB minus 2g sine 30 is equal to 2a, so that gives you one method mark. You get your second method mark for getting 4g sine 60 minus TBC is equal to 4a. A third method mark for getting TBC minus TAB minus friction is equal to 3a. Your next method mark comes from substituting in these values. And then you get an answer mark for getting 9a is equal to g bracket 4 sine 60 minus 2 sine 30 minus 3 mu. Now I did it a slightly different way, whereas I worked out what mu was to start with, so I did this section here and then substituted in. Either way, you will still get the marks. So then from here you need to rearrange this equation to find mu. So you'll find that mu is 1/3 of 2 root 3 minus 1 minus 9a over g. Now mu has got to be greater than 0, okay, as we said, because there is going to be friction on this section, so the friction has got to be greater than 0, and you can rearrange for your 7th mark, which gives you an answer mark here of what you've been asked to show. Next, part B, you've got a mark for working out your friction. Mu is equal to 2/3 of root 3 minus 1 is one method mark. Finding friction B is 2 root 3 minus 1 lots of g is the second method mark. Then for using the contact force formula for your reaction force, put your friction force all squared, and your 4th mark comes from getting the answer 32.7. If you found this video useful, please share, like and subscribe so we can all get great at maths.
If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time!